everyone. I'm Meghamala from Electronics and Communication Department, working as Assistant Professor from Institute of Aeronautical Engineering. So, today's topic is all about timing control. So, before we go forward, what is a timing control and what are the topics that we have to cover in this particular topic? We will discuss slowly one by one. So before we go forward, let me discuss about the last class. Let me have a recapitulation about the last class. In the last class, we had discussed about the procedural constraints, right? Procedural assignments. So here also in the timing control, we come across the procedural assignments, though it is a non-blocking or as well as the blocking assignments, continuous assignments we will come across in this particular topic. So, what is the timing control? We all know the controlling some devices, some electronic devices, the combination or as well as the sequential circuits. We will see the circuits will follow some delays. Okay, with some delays they will produce the output. Okay, not only with the output but also we see some delay constraints with respect to the input as well. So the behavioral model in the behavioral modeling in the Verilog, it contains the procedural statements. So yesterday in the previous session we had discussed what are the procedural assignments. So coming to the procedural assignments, we discussed about what is the assignment, definition of the assignment. So what is an assignment? Assignment is nothing but considering the values into a variable. That means what? Considering some values, taking up some values and dumping that particular values onto the variables. Different variables are nothing but the assignments. Okay, so we had discussed about the blocking and as well as the non-blocking assignments, and also we had discussed few procedural assignments, procedural, continuous and procedural continuous assignments. Okay. So here in this particular procedural assignments, we say that to the left hand side equals to the right hand side we have the expression, and to the left hand side of the equation we will place some values. Okay, we'll find some variables. Okay, so we will dump some values onto the variables. These are nothing but the assignment. So here in the procedural assignment, the variables, it could be of scalar or a vector. Okay, and also we will see onto the left hand side a part bit select and as well as the path select. Okay, and also the constraints regarding the left hand side of the expressions, it could be in terms of registers, time, real time and delays. Okay, all these constraints we will see onto the left hand side of the expression. So coming to the timing control, the behavioral model in Verilog, it contains what? Procedural statement. So procedural statement consists of some variables. In that variable, some values have been dumped into the variables, and the representations of that particular variables, it could be in terms of register, timing controls, timing devices, real time and so on. Okay, and these the statements which control the procedural statement, it controls the simulation and manipulation variables of the data type. So what it does, it controls and also it manipulates. So in order to produce a proper right hand side output, we can manipulate the values into the variables. Whatever the values that we are dumping into the variables, we can manipulate in order to control the output. So here these statements, these procedural statements, we can control and also we can manipulate the variables in the data type, and each of the procedure has an activity flow associated with it. So here we have seen in the last class the blocking and the non-blocking. We have said the blocking and the non-blocking assignments, statements. So what does it blocking and non-blocking means? So these two assignments, they states that we see there is no dropping or else we don't see any breaking of the statements. We see the continuous flow of the statements. Okay, right from the starting of the procedure till the end of the procedure, we see the continuation flow. We don't see anywhere the breakage of the flow. So here also this procedure the procedural assignments or whatever the continuous assignments that you are considering, we see there is an activity flow associated with it. With respect to the assignments that you are considering, you see that there is a flow, there is an activity flow would be seen associated with that particular assignment. And also during simulation of the behavioral modeling, all the flow defined by the always and initial statements, okay, and that starts with the simulation 0. So as per the yesterday's session, I'm saying that the constraints simulation in the behavioral modeling, all the simulations will be done with respect to the in the always and the defined state, always and the initial statement. So always and initial. So in between these statements, we will see the variables, or else we will see the values which are placed onto the variables, and we will see the manipulations and the controlling of the things will be done only in this always and the initial statements. In the always and the initial statements, all these things, manipulations and controllings of the devices, or the controllings of the outputs can be seen only in these two. Okay. Next, in this model, the register variables A and B are initialized to binary 1 and 0, and the simulation time with 0. So here, as we see the input and the output, the simulation time with respect to the output and the input. For suppose this is A and B. These are my inputs, and my time at t is equals to 0, it starts with respect to the input. Okay, without time t is equals to 0, the procedure will not start. So always at time t is equals to 0, the proper procedure, or else a proper propagation of the particular input, or else with respect to the input variables, the timing constraints will start at time t is equals to 0. And also here it's a particular instance will give the variables as t is equals to 0 or 1. The binary numbers only can be given for the inputs. Okay, for that is 0 or 1s. And this initial statement containing a begin end block, also called sequential block of statements. So all these things, all the initialization of the inputs and as well as the output, all the statements we will be writing only between the begin and end block. That means what? Here begin, all the initialization, int a is equals to 1, b is equals to 0, and we will be ending up. So all the initializations of the input can be given only the begin and end block. Okay, so and also see, this is a particular example. In this example, we will see how the initialization of the inputs can be made, and also with respect to the always and the initial blocks. So and also remember important thing, initial, it is not continuous. Not continuous. It is this statement will not repeat. Only it repeat once. Okay, more than once it will not repeat. Whereas always it can repeat multiple times. Okay, more than 2 times or 3 times. Always statements always repeats more than twice. Whereas the initial statements we will be considering only it executes only 1 time. Always statements it executes more than 2 times, whereas initial statements it executes only 1 time. So here module behave and register 1 is equals to 0. So what does this register means? Register is nothing but, as I said you, to the expression, to the LHS, we can denote, okay, we can denote the variables or else the values with respect to the register nets. Okay, nets, that nets could be of vector or scalar. Okay, so register 1 is to 0. That means 2 bits of data we have, and that we have stored in the register with inputs A and B. And I'm initializing initial begin A is equals to 1, 0, and B is equals to 0, A is equals to 1. Okay, and I'm ending begin and end. It's done. Next, coming to the always. Okay, in the procedural continuous statement, we will use 2 keywords, initial and as well as the always. Always can be repeated twice or more than twice, but initial is executed only once. So here always begin. Here this is a timing control. So here with a delay of 50 nanoseconds, my input has been delayed with a NOT gate. Okay, negation of A, and ending. And always I'm starting one more time, as it can be repeated. Always block can be repeated more than once, right? So here for my input, another input B, my delay, I'm considered 100 nanoseconds and with the negation of B. And finally, I'm ending up with the terminating with the end module. So here from this example, you have to remember one thing, that the timing control always will represent in the always block. Okay, in the always block, the delay, the timing delay, the timing control of that particular inputs can be instantiated only with respect to the inputs, and that too within the always block. Okay, whereas in the initial, we are simply initializing the inputs. Okay, inputs and the values pertaining to that particular variables. Okay, here my variables are A and B as inputs, and the values that I am giving, it should be in terms of either 0 or 1. So I am initializing A as for 0, A as for 1 and B as for 0. Okay, so the initializing and the dumping of values onto the variables, all this initializing part can be done with respect to the initial. In this initial block, it will be executed only once, whereas the always block, it executes more than once. Okay, so the redundancy can be achieved with respect to the always block, whereas the redundancy will not be achieved with respect to the initial block. So here in the always, we are presenting the timing control with respect to the input, whereas in the initial, we are just initializing the inputs with respect to the binary numbers 0 or 1. And finally, we are terminating the keyword with end module and an end module. And the delay in the assignments, how the delays are produced, or else how the delays can be calculated in the assignments, we will see. So delays in the assignments, this is not for the synthesis. So here in the delay assignment, delta t time units, it pass before the statement is executed and the left hand assignment is made. So here the left hand assignment is made, and before the statement is executed, you have to remember this word, before the statement is executed, and the left hand side it will be made. All the timing controls, all the timing delays are represented with respect to the LHS, left hand side. Okay, and that too before the statement is executed, and we are denoting it with delta t time units. Okay, delta t time units. With intra assignment delay, the right hand side is evaluated immediately. So this is with respect to the delay assignment, and it is within the intra assignment. That means what? Within the block. Okay, within the initial block or else the always block. Remember that the right hand side is evaluated immediately. Whereas here, the time delays we are mentioning onto the left hand side, and these will be executed only after the statement is executed. These will be processed. Whereas intra assignment delay, that means what? Within the module, within the block, initial or always block, we see the intra assignment delays will be observed, and that too with respect to the right hand side is evaluated, not with some delay but immediately. And there is a delay of delta t before the result is placed in the left hand side. So always here with respect to the intra assignment delay, there will be a delay, okay, of delta t, and that delay will be processed before it is placed to the left hand side. So before we are placing some values into the variables to the left hand side of the expression, we see there is some delay, okay, and that delay is evaluated immediately, and all this process will be happening with respect to the right hand side. Okay, before the value is dumped onto the left hand side onto your variable, the manipulations and the controlling can be done with the timing control delta t. All these changes will be seen immediately only at the right hand side. This is nothing but the intra assignment delay. Okay, if another procedure changes a right hand side signal during delta t and it does not affect the output. So here immediately if you see some changes happening in the right hand side, there is no changes occurs at the output. Okay, the changes will not occurs at the output with the time delay delta t. and here the delays are not supported by the synthesis tool. So here in the synthesis tool, for example, if you're considering any kind of synthesis tool, we see that there is no delays. Delays won't be considering. So here you see the delay in assignments only for the not for the synthesis. Okay, for non-synthesis procedure only we will find some delays in the assignment. And here is a syntax. So this is already we have discussed what is a procedural assignment, and for this procedural assignment, on to the left hand side we see the variable and right hand side we see the expression equals to the operator. Okay, equals to is an operator which separates the expressions with respect to the variable initialization. Okay, and for delay assignment, we see a delta t, a timing control of delta t onto the left hand side of the variable. Okay, this variable consists of some delays. We represent that with delta t. That means what? Hash 20a, which is equals to a bar 0. Okay, this is how we will represent. And intra-assignment delay. So this intra-assignment delay is nothing but variable onto the left hand side, and onto the right hand side we see the expression with respect to the delay. That means what? In the previous slide we had discussed whatever the changes are happening with respect to the right hand side, it should be happen, or else the controlling or the manipulation should be happen immediately, and that too within the right hand side of the expression. So the manipulations and the controlling, everything will happen with respect to some delays. Okay, that delays will be happening only with respect to the right hand side before we manipulate, and after that the whatever the output that we are assigning, and directly we are dumping onto the variable. So that's the reason for intra-assignment delay, the delay delta t is mentioned onto the right hand side. The delta t is to be mentioned onto the right hand side, whereas for delay assignment, onto the left hand side the delays are being represented. So this is a small syntax to be followed when you are considering the assignments based on the delayed, if you are considering the assignment based on the procedural, if you are considering assignment based on the intra-assignment delay. So whatever the procedure that you are following, make sure that in the syntax the representations of the timing control with respect to the LHS and RHS should be maintained properly. So this is a syntax that you have to follow. So in the blocking, the delays in assignments with respect to the blocking and as well as the non-blocking, that is RTL assignments. So coming to the blocking procedure assignment must be executed before the execution of the statement that follows in a sequential block. So here the blocking assignment, what does it say mean? The blocking procedure assignment, this assignment must be executed before the execution of the statement. So before the execution of initial or always statements, the assignment statement must be executed before these two. Okay, before these two the execution should happen. So that is nothing but the blocking procedural assignment. The blocking procedural assignment, it must be executed before the execution of the statements. That means the syntax of the blocking procedural assignment is nothing but to the equals to is the operator. To the left hand side the value is to be dumped onto the variables, and to the right hand side there is a timing control followed with the expression. That is what? Here variable which is equals to timing control delta t and the expression. Okay, so this is for the blocking procedure. That means what? Here value is nothing but the data type that is valid for the procedural assignment statement. So here it is some data type. Okay, and equals to is a operator. Which operator? Assignment operator. And the expression is nothing but the and timing control is a optional intra-assignment delay. So the timing control is, it's a delay, intra-assignment delay. Okay, got to know value, timing control, delay and the expression. Equals to is a assignment operator. So whenever you are writing a syntax for with respect to the statements that you are considering, this is to be followed. So the timing control delay, it can be either control or an event control. So it can be any delay control or else an event control. Already regarding the delays, in the last module we had discussed what sort of delays are there, okay, and how many kinds of delays are there, event delays, timing delays, and so on, isn't it? So here the timing control delay, it could be either delay control or event control. For example, here at the rate pause edge clock. So we will see this pause edge clock only with respect to the flip-flops. Okay, we have seen in the last class coming to the designing of examples of the assignment statements, isn't it? So what sort of examples that we had considered? The sequential combinational assignment statements or the sequential assignment statements were considered flip-flops latches, isn't it? So for flip-flops, we will see from 0 to 1. It is a high edge clock. Okay, positive clock. Whereas from high to low, this is a low edge clock. Okay, that is a negative clock. This is a positive clock and this is a negative clock, isn't it? So here, the timing control delays, it could be either delay or else the event control, and for this is how we represent at the rate pause edge clock. If it is negative edge clock, the representations would be followed with this at the rate pause edge clock or else at the rate negative edge clock. Then the expressions in the right hand side value of the simulator, it assigns to the left hand side. So here the right hand side of the simulator, it assigns to the left hand side. How is? Just followed with the delay controls, with how much of delay, okay, that you are considering. That means what? The equals to assignment operator, it just used for procedure assignment and also used by the procedure assignments and conditional. So remember that equals to assignment, this assignment operator, it is used for blocking procedural continuous assignment statements, and also for procedural continuous assignment statement and continuous. For blocking procedural and continuous. For these three, the assignment operator equals to is used here. So register A is equals to 1 or else 0 or 1. Register A is having a 3 which is equals to 1. That means what? Out of my 0 to 10, I have selected a bit. Which bit I have selected? I have selected a bit 3. A bit 3 is selected. So register A of 3 which is equals to 1 and a part selected. So this is a bit and here it is the part, and this part consists of all the registers R1, R2, R3, so on, R10. So this is a part R, this is a part R2. So for bit selection, I have selected only a bit, okay, from the register 3, this bit register 3, and for part select, I have selected register 3 is to 5, totally 5, 6, 7, 8. So totally 8 bits I have selected, 8 bits. So 8 bits I have selected with 8 bits which is equals to 7, that is a part select. And memory, how much of memory? I am storing all these 8 hexadecimal of bit in the address. I am storing the value, some value of hexadecimal number into the address bit. That is a memory A of address. That is assignment to a memory element. So here I am assigning that particular word or else the bits into a address bits, the memory. Finally, carry or concatenate, accelerate, that is register A plus register B, carry and concatenate. So if you add both, you will get some carry and as well as some bit, right? So concatenate I'm doing with respect to A and B, and the carry bits, whatever I'm getting, I'm just accumulating in the carry. Okay, so this is how, with a logical understanding, we have to write the syntax with respect to the given procedural assignments. If it is a continuous procedural assignment, if it is a assignment, if it is a continuous procedural assignment, if it is a procedural assignment, whatever the assignment is there, always remember on equals to is assignment operator. It must be there. On to the left hand side, we have to represent the variables, and on to the right hand side, we have to represent the expression. So here, if you observe, this is the operator assignment. On to the left hand side, these are the variables. Register A of 3, and these are the values. A is a variable and 3 is a value. So I am dumping some value, or else I am representing some values onto the variable. And 1, 7, 8 FF and register A and B are nothing but the expressions with respect to the assignment that you are considering. So this has to be followed, and these are nothing but the comments. Okay, comments should be written. So this is a bit select and it's a part select, and I'm doing the concatenation and as well as the carry bits which are need to be accumulated in the carry. So for this non-blocking, previously we had discussed about the blocking assignments, how the delays are to be mentioned with respect to the expression and the equals to, that is the assignment operator. And now we will see for non-blocking assignments, that is RTL assignments, register transfer language assignments, how the delays or the timing controls can be represented. So for non-blocking procedural assignment, it allows you to schedule assignments without blocking the procedural flow. So here this non-blocking assignments, it will help us to schedule the assignments. Okay, it will help us to schedule the assignments. That means what? It will help us to dump the value, or else it will help us to take the values and place those values onto the variables without blocking the flow. Okay, without blocking the flow. This non-blocking assignments, they will help us, okay, in order to dump the values onto the variables. And the syntax for this non-procedural blocking assignments is value non-blocking. It is non-blocking, right? Value less than or equals to timing control and coming up with the expression. So this is an important thing to be remember. For non-blocking assignments, less than or equals to is the assignment operator. Okay. So, where value is a data type, that is a valid for procedural assignment statement. Value always indicates it's a data type. And also, less than or equals to is a non-blocking assignment operator, isn't it? So, for blocking assignment operator, for blocking assignment, the equals to is a operator. Assignment operator is a equals to. For non-blocking assignment, it is less than or equals to. So this is an important point to be remember. And the timing control is the optional intra-assignment timing control. So here this timing control is an option. Sometimes with respect to the assignment statements that you are considering, you may see the timing delay, it would be onto the left hand side. Okay, onto the variable side, the timing control, the delay would be appear. And also with respect to the intro assignment statement, sometimes it appears onto the right hand side. Okay, with respect to the expression. So this is an optional intra assignment timing control. And for non-blocking, less than or equals to, and value is nothing but a data type. Okay. So the timing control delay, it could be either delay control or event control, and this is how we represent. And the expression in the right hand side value, the simulator assigns to the left hand side. So the expression is the right hand side, and the value simulator assigns onto the left hand side. That means what? Here you will see sometimes the delay onto the left hand side, not sometimes, only with respect to the right hand side. And for non-blocking assignments, the operator is the same operator simulator uses to less than or equals to relationship operator. So for non-blocking operator, we will see the assignment operator, it would be less than or equals to relational operator. Okay. And the simulator interprets what? Less than or equals to operator to be rational operator, when you see it in an expression. So sometimes in the expression, we will see less than or equals to, isn't it? It is less than, it is a relation operation, right? Relational operation. Relational operator. Less than and equals to. Okay. Basically, when you observe these two, you might have recollected this magnitude comparator. In the magnitude comparator, when my bits are A and B, we need to observe three conditions: A equals to B, A less than B, and A greater than B. So we need to observe these three conditions, isn't it? So when you observe these three conditions, equals to, greater than, and less than, equals to, less than, and greater than, these three are nothing but the relational operators that we can consider. So here also in this non-blocking assignments, the operator, the assignment operator we represent is less than or equals to. Whereas for blocking assignments, equals to is the operator that we have to follow and remember. So the simulator, it evaluates what? The right hand side and schedules the assignments to the new value. So here the simulator, sometimes if you see at the right hand side, the delay, the timing control, if you see, observe onto the right hand side, what it should do, it just schedules the assignment to the new value. Okay, it schedules the assignment to the new value to takes place a time specified by the procedural timing control. That means what here, as I said we can manipulate and we can control. Okay, we can manipulate and control the values which are needed to dump down to the variable. So here the assignments, we can schedule the new values that are needed to take place in the time specified. And also at the end of the time step, the delay has expired to the appropriate event has taken place. So when the delay expires, okay, when the delay completes its task, what happens at the end of the time, we see the other events taking place. So suppose a time delay time. Okay, a time t is equals to 10 nanoseconds. I've completed my task. So what happens? The next task will come into existence. Okay, so the appropriate event will take place immediately without any delay. Once the delay timing is completed, once the time control is finished, what happens? It will help us, or else it will help us to take out the next event immediately. That is what this sentence says. And the simulator executes the assignment by assigning the value to the left hand side. So here the simulator, it will help us, or else it will execute the assignment. The assignment, it will execute the assignment. It can consist initial or always. Okay, only after the value giving to the left hand side with respect to the right hand side. And here is a particular syntax which is to be followed. So module evaluates to out, just initialization, and the output register out, and here input ABC, input register ABC using a net, and initial, in the initial I am beginning with A as 0, B 1 and C 0. I am just ending. This part is can executed only once, whereas always can execute more than once. It can repeatedly. It can repeats. Okay. Redundancy will be observed when it comes to the always, whereas initial block, it only executes one time. So here initializing begin with respect to inputs ABC 10 010, and I'm just ending. Coming to the always C. Okay, here C input, I'm having a delay of 5 nanoseconds and the output is C. Okay, not C. And always at the rate posage C. So for this particular input C, my delay is observed at 5 nanoseconds. Okay, and the output for C, not get C, right? Negation of C. So for this, the positive edge clock I'm applying with respect to the C input and begin A less than or equals to B. So these are non-blocking assignments. Non-blocking assignment statements. Why? Because A less than or equals to B and B less than or equals to A. So non-blocking assignments representing or initializing with respect to inputs and as well as the inputs, and I'm ending up the whole with the end keyword and terminating the syntax with the end module. So here in this particular example, you have to observe initializing keyword module, initializing portless, initializing the things input and output, as well with respect to the delay timing control. Output is registered as out and the inputs are stored in the register A, B, C. Initializing the things begin A, B and C. I'm just completing this task. Okay. The executing of this task is completed. Only once we represented, only this thing we are represented with A, B, C, and I'm just ending up, it is done. Okay. Executed only once, it is done. Coming to the next one, always statement. In the always statement, I am representing the non-blocking assignments with a pause edge C. Okay, for particular C or input, pause edge clock I am just representing. Why? Because it is a non-blocking assignment, isn't it? So, with a delay of 5 seconds and the output I can observe is negation of C. And later, I am beginning this always with a non-blocking assignments. How? With respect to the LHS and as well as the RHS. So my LHS and RHS are comprised of the variables. So A less than or equals to B, one thing, and B less than or equals to A. Okay. After initializing the non-blocking assignments, finally concluding it with the N and terminating it with the N module. Okay. So this is all about the timing control. How the timing control mechanism can be observed in procedural continuous assignments, continuous assignments and procedural continuous assignments. Okay, procedural assignment, continuous assignment and procedural continuous assignments. How the timing delay or else how the timing controls can be represented with respect to the assignment operator, with assignment operator towards the left hand side and as well as the right hand side. Okay, so today we have discussed the timing controls based on the blocking statement and non-blocking statement. Okay, with respect to the concerned syntaxes and also the operators. For blocking operator is equals to simply plain equals to the LHS and to the RHS, whereas non-blocking operator, this is for blocking operator, it is for non-blocking operator as well as LHS and RHS. And also the delay will be considered, it could be considered either in the begin or else initial, but begin or else in the always statements. But always statements can be executed more than twice, but as the initial statement, it can execute only once. So, this is all about the timing control. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.